It's good to see you all for another lesson. Sorry if you hear the click on and click off of the air conditioning over and over again. That's the school thing, not a me thing. Also, bad hair day, so if you care to know. Here we go. We're getting into it. 7.3. We're learning about a lot of different things. 3, actually. Yes. Power of powers, power of products, and power of quotients. Three new properties we'll get to. Before we get to those, let's go ahead and remember the properties we've been working with. Property 1, anything to the power of 0 is what? 1. Good job. Let me say these properties you will want to memorize. If you don't have these memorized, okay, thank you, Skyward. If you don't have these properties memorized right now, be working on these because they aren't going away. You will want to know them. Here the formatting looks like it got a little wonky. This is saying a to the power of negative m. Once again, if we have a negative exponent, we take it and we move it. So currently, this a to the negative m is in the numerator. When we take it and move it, we'll move it to the denominator. By moving that into the denominator, it becomes a positive exponent. Here, this is ugly. It's supposed to be 1 over, it's supposed to be 1 over a to the power of negative m. The same idea though. Because we have a negative exponent, we want to switch sides. That action of switching sides makes the negative exponent a positive exponent. So here we would write a to the m power over 1, but when we simplify this, that would just reduce to simply a to the power of m. That last property that we've talked about so far is a to the power of m times a to the power of n. Well, because we have two of the same bases, both of these exponents have a as that base, we are allowed to just add together the exponents. So we know that a m plus n will be the same thing, will give us the same result. So those are the 4 properties we've already talked about in 7.1 and 7.2. Now, we're going to talk about a power of a power. Do you see here in example 1 how this 4, oh man, the formatting, what in the world? I'll just write it again. Do you see how that 4 is our base? It has an exponent of 3, but then it has another exponent too. There's 2 powers, power to a power. Well, let's think of this. And I'll just write off to the side right now. If we had something like, let me think, let's just do something nice and simple. If I had 7 squared, let's remember that we can write that out. We're doing 7 times 7. Well, here, when we see 4 to the third squared, we could write that out if we wanted to, and we do, as 4 to the third times 4 to the third, because we're taking this piece and we want to do that twice. We want to multiply it by itself. Well, we learned last class, well, since these bases are the same, that would give us, thank you, pen, 4 to the 6th. So we can kind of debunk, we can pull all this stuff apart if we want to. Let me show you the easy way to do this. Oh, and this formatting is not making it easy. I don't know why these parentheses are big and then they're small. Here, let me zoom back in. What's the connection when we look at this 3 and the 2? Do you see how if we multiplied 3 times 2, that would be the same thing as 4 to the 6th? That's the hint. That's what we're doing here. So the power of a power property says this. When you have an exponent on the outside of the parentheses, so that would be like, well, it's supposed to be like n. N is the power on the outside of the parentheses. We multiply the exponents. So because n is on the outside, to simplify it, we just do m times n. Here's some quick examples. All we have to do, oh, I see 2 powers, I see a power, I see a power. All we have to do, 7 4 times 3, which simplifies to 7 to the 12th. Now, shoot, I did this in the last video, I'm doing it now. We need to be good about figuring out what's going on here. So in my calculator, I'm going to go ahead and type that in. 7 to the 12th power is huge. This is a bad example. Wow, okay. This example, don't simplify. Because it's too large to even bother. Forgetting that happened, moving on to example 3. You're exactly right. What are we doing? Oh, we see this exponent on the outside, so we throw it in. We have our base 3, 6 times 3, giving us 3 to the 18th. Yeah, let's just go ahead and leave it at that for now. Here, same exact thing. We have an exponent instead of a number, but who cares? Same process. X, 2 times 4 gives us x to the 8th. Now, we're going to add a couple elements in here. In this example, we see 8 times x all to the 3rd power. A lot of students will show me this. I'm going to show you this ahead of time, and I'm going to tell you it's wrong. A lot of students would want to write 8x to the 3rd power. You're close. However, let's see this. We want to take it base by base. 8 is its own base, as well as x. So, when we take this 3, we're going to multiply it by the exponent of both 8 and 1, or 8 and x. So the correct answer here is 8 to the 3rd, x to the 3rd. Let's see if that works out nicely. It's nice enough to go ahead and write down. When we do that math, 8 to the power of 3, that gives us 512, x to the power of 3. So this is the second rule or the second property that we're learning today. When you have an exponent on the outside of parentheses, so very similar to last time so far, when that exponent is on that outside, we multiply, except we're going to use this fancy word. We're going to distribute to each base. We're going to distribute. That just gets us in the mindset of doing those loops. So here, if you can get around this notation, sorry, we're starting with 4 times p to the third. We just need to make sure we're given this 3 to both of those bases that we see. So our answer is going to end up being 4 to the third p to the third. When we see a number base, we want to simplify that. So 4 to the third, or 4 times 4 times 4. When we simplify that, we get 64p to the power of 3. Yay! Here, go ahead and take a look at 7 and 8 and pause, work on it, see if we can work it out. I'm going to explain them here in 3, 2, 1. Here we go. Hopefully you paused, you tried to work on them, and you feel good about yourself. Ooh, because you're geniuses. Here we have 2 times x all to the power of 5. Let's put those 1s on those exponents. Then we're giving that 5 to both of those bases. So our answer will be 2 to the 5th, x to the 5th. When we work out what 2 to the 5th is, we get 32 x to the 5th. Example 8, interesting element. What we're seeing here is negative 3x squared. So let me throw in my 1s for my exponents just so we can see what's going on. Still going to give my 2, distributing that in. This is what's interesting about this problem though. When we see that negative 3, we actually want to make sure we put that in parentheses. Our answer is going to be negative 3 squared, x squared. When we simplify that, we'll get 9x squared. It's really important that we put these parentheses. Let me show you why. If you have a calculator nearby, if you have your phone, calculator, something that you could tippy-typey in, do this. Type in parentheses negative 3 parentheses squared. When you type this in, your phone, your calculator will give you 9. Because what we're doing is negative 3 times negative 3. If you write this problem without the negative, without the parentheses, okay, it's not going, oh. If you just did this, so go ahead and type that in your phone or your calculator without the parentheses. When you do that, your answer is actually negative 9. Because what's happening is that it's taking 3 times 3 and then making whatever that answer is negative. We have to be really careful because we just got 2 different answers. 9 and negative 9 are very different numbers. So we have to be cautious. We are on to the, what happened here? We are on to the third property of this lesson. Oh gosh, where we see 3 over 4 to the power of 3 is what that should look like. What this is saying is this. There's really more bars. We don't need this bar. What this is saying, we still give that exponent 3 to each of my bases. It's the exact same thing. Nothing's changed except now we just have a fraction. So we have 3 to the third, we have 4 to the third. Then we just figure out what those numbers would be. 3 to the third is 27. 4 to the third is 64. That's all we're doing. So, when you have an exponent on the outside of parentheses, we distribute to each base. It follows the same exact rules as what we just did. Now we have 3 examples that we'll go through. I just am laughing at how botched these notes got. This should still be on the top page. When we have 2 over 5, all to the power of 3, we still want to give that 3 to each of my bases. Here I see a base 2 and a base 5. So I still just give a base there, or give the 3 there, and I figure out what that's going to be. 2 to the power of 3 is 8. That's a weird looking 8. There we go. 5 to the power of 3 is 125. There's your final answer. Here in 11, I'll go ahead and show you what this should be. It should look like 2 to the power of 3 over 3 to the power of 2, all to the power of 2. So go ahead, take a minute, pause the video, try to work this out. I'll explain it in 3, 2, and 1. Here's a power outside of parentheses. We still distribute it to each of those bases. So what we're doing, I'll write it out a little better so we can see. We multiply the exponents. So here I'm doing 3 times 2 and 2 times 2. Maybe I'll color code this even better. There we go. Which 3 times 2 is 6. 2 times 2 is 4. I type that in. That gives me 64 over 81. Cha-ching. The last example for today, we have 2 times x to the third power over y times z, all to the power of 3. Take a minute, pause. I believe in you, you can do it. I'll explain in 3, 2, and 1. We see that power on the outside. We distribute it to each and every, so I'll choose a different color, base. My question, did you remember to see that 2 as its own base? We can put a 1 there, we can put a 1 with the y, and we can put a 1 with the z. So what that becomes is 2 to the third, 1 times 3 is 3, x, 3 times 3 gives us 9, y to the third, z to the third. Are we done? Are we good here? We're really close. The only other thing that I want us to do is simplify these numbers. So let me take this. Let me take all of this and just say the only thing left to do is to fix up that 2 to the third power. that would give us 8x to the 9th, y3, z3. Cha-ching. There we go. Thank you for sticking with me, for bearing with me. I know there were some goofs, so sorry about that. Hopefully this was still helpful. Have a good day.